Now let's go to Chapter 2. Lesson 1. Now that we have learned about network models, layers, and addressing, let's move on to the next topic, Ethernet LANs. Of course, you remember that LAN abbreviation stands for Local Area Network. In this section, we will delve into basic Ethernet operations, as well as cover repeater, hub, and bridge operations, and Ethernet switch operation. We have learned a new term, Ethernet. So Ethernet is a family of computer networking technologies for local area networks, or LANs. Ethernet was commercially introduced in 1980 and standardized in 1985 as IEEE 802.3. Ethernet has largely replaced competing wired LAN technologies. The Ethernet standards comprise several wiring and signaling variants of the OSI physical layer in use with Ethernet. The original 10-base-5 Ethernet used coaxial cable as a shared medium. Later, the coaxial cables were replaced by twisted pair and fiber optic links in conjunction with hubs or switches. Data rates were periodically increased from the original 10 megabits per second to 100 gigabit per second. Can you imagine what a huge bandwidth it is? 100 gigabit per second. By the way, to understand the amount of this bandwidth, just compare with your connection. Systems communicating over Ethernet divide the stream of data into shorter pieces called frames. Each frame contains source and destination addresses and error-checking data so that damaged data can be detected and retransmitted, as you saw in previous lectures. As per the OSI model, Ethernet provides services up to and including the data link layer. Since the commercial release, Ethernet has retained a good degree of compatibility. Features such as the 848-bit MAC addresses and Ethernet frame format have influenced other networking protocols. So let's a little bit speak about the situations about the process which is called collisions. Collisions are used by Ethernet to control network access and shared bandwidth among connected stations that are trying to transmit at the same time on a shared medium, such as network segment. Because the network medium is shared, a mechanism must exist whereby the network stations can detect network availability so that they do not transmit at the same time. The mechanism is collision detection. Collisions occur when two frames try to use the same network segment at the same time and both frames are lost. Not unlike two people trying to talk at the same time. as you might suspect, collisions in networks and conversations are best avoided. However, collisions in a shared environment cannot be avoided, whether that shared environment is a network segment or the air of conversation. As you can see from the picture, this picture shows what happens when a collision occurs on a network segment. Station A attempts to send a frame across the network. First, Station A checks to see if the network is available, carrier sense. If the network is not available, Station A waits until the current sender on the medium has finished. Let's suppose that Station A believes the network is available and tries sending a frame. Because a network is shared, it is a multiple access, so many stations are connected to the network. Other stations on the same network segment might also attempt to send at the same time. For example, Station B. Shortly after Station B attempts to send traffic across the line, both Station A and Station B realize that another device is attempting to send a frame. This situation we call collision detection. Each station waits a random amount of time before sending again. The time after the collision is divided into time slots. Station A and Station B each pick a random slot for attempting a retransmission. Should Station A and Station B attempt to retransmit at the same time, they extend the amount of time each waits before trying again, decreasing the chance of resending data in the same time slot. The maximum number of the retransmissions for the same data frame is 16. If the transmission fails after 16 consecutive times, the network is considered unavailable. Reducing the number of collisions in a LAN is essential to the design and operation of the network, just as reducing the amount of traffic in the city is crucial to reducing delays. Increased collisions result from too many users and devices on the network contending for network bandwidth. This contention shows the performance of the network from the user's point of view, yielding the most frequent call to the help desk. The network is slow today, for example. Breaking up or segmenting the network is the common way of reducing this network contention. Network segmentation occurs when a network is divided into different pieces joined together logically with a bridge, switch, or a router. About these devices, we will talk a little bit later.